Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on the 2.4 worksheet from the packet. This is on putting together polynomial equations and also finding the average rate of change. So when you want to write a polynomial function with least degree with the integral coefficients that has a given zeros. So the given zeros are all these numbers that are, with the commas around them. What we want to do is take the zeros and use the fact that to put together a factor of a polynomial, it's going to look like this. It's going to be the x value minus whatever your zero value is, whatever one of these individual numbers are. Then it says to expand on only the even number problems. I'll expand a couple of these just because it's pretty easy, but just practice it some more over here on your own if you want. So first, I'm going to put together some of these polynomials. It's really, really easy. All you got to do is just remember that to put together one of the factors, it's x minus the 0. You got to remember that it's subtracting each time. But other than that, it's really, really easy. Here we go. So putting together this polynomial number 1 looks like this. So I put parentheses, and then it's going to be x minus my first 0, which is a negative 2. And then right next to it, I put the next factor. So to put together the polynomials, just multiply these factors together. And the next one's x minus 2. And then the last one is x minus a negative 3. Then we just make it look a little bit nicer. So subtracting a negative is the same as adding. So this turns into x plus 2, x minus 2, and then x plus 3. So this is our polynomial in what we like to call factored form. And that's as much as you needed to do with the odd problems. When it says to expand, that just simply means that you're going to FOIL or distribute everything out. And the advice that I'd give you for that is to distribute each one just 2 at a time. Okay, so do 2 factors at a time. So if I want to expand this one out, I'm going to FOIL or distribute these out. So I'm going to do x times x. X times x is x squared. X times negative 2, which is negative 2x. And then I do 2 times each of those. So 2 times x is a positive 2x. And 2 times negative 2 is negative 4. So if I combine all the like terms in here, I have x squared. And then minus 2x and plus 2x cancel out. And then I have minus 4. All right, now we have to add in the last part of it, which is that x plus 3. So we're going to FOIL that part in as well. So we take x squared and multiply that on x, and we get x to the 3rd power. X squared and multiply it times 3, and we get 3x squared. And then negative 4 times x is negative 4x. And negative 4 times 3 is going to be negative 12. We can't combine any of the like terms any further, so this is our polynomial when we're all done in its expanded form. But remember, when it's written out in factored form like we initially had, which was x plus 2, x minus 2, x plus 3, that's good as well. These 2 polynomials are the exact same, it's just they're in different forms. This is factored form, this is expanded form. All right, so one little rule change for the factors is when you get a 0. So if I write it out, x minus 0, and then the next factor, x minus negative 1, and then the last one, x minus 5. X minus 0, the reason it's kind of a rule change and that it's a little bit different is that if I were to subtract or add 0 onto anything, it doesn't change the number at all. So like if I had a number like 5 and I subtracted 0, it'd still be 5, right? So if I had negative 3 minus 0, that doesn't change anything, so it's just negative 3. If I had x minus 0, it's really the same as just saying x. That's the reasoning behind this. So when I see x minus 0 like this, I'm just going to change it to an x. X minus a negative 1 changes to x plus 1. And then x minus 5 just stays the same. So this is the factored form of the polynomial. Now I'm going to go ahead and do FOILing to distribute it in. So x times x is x squared. X times 1 is 1x. And I'm all done with this part of the distributing. Now I need to multiply that times x minus 5. And FOIL again. X squared times x is x to the 3rd power. X squared times negative 5 is negative 5x. 1x times x is 1x squared. Oh wait, and that should have been x squared times negative 5. That's negative 5x squared, my bad. And then x times negative 5 is going to be negative 5x. So that's where we get the negative 5x from. Now combining like terms, x to the third is all by itself. Negative 5x plus 1 is a negative 4x squared. And the negative 5x all by itself is just negative 5x. So there's our expanded form of the same exact equation. So they're interchangeable, they're the same thing. Okay, and then the last rule change, well, there are two more rule changes actually. The next rule change is when you have a fraction. So when we want to write that out as a factor, here's how it looks so far. X minus 5 over 4. And then another one at x minus 1 over 3. And then x minus negative 5. So nothing different, all kind of the same stuff that we've been doing. But when you have a fraction, to turn this into a factor, you move the denominator in front of the x. So the 3 moves in front of the x, the 4 moves in front of the x, and you end up with 4x minus 5 and 3x minus 1. And then this is just going to be x plus 5. So this is the expression in factored form. I'll just kind of leave that one alone. That's, I'm not going to expand anymore. That's it. All right, now for this one, when it has a multiplicity, what you need to do is just add that as an exponent onto your factor. So if the 0 is at 5, then it's x minus 5. And then the multiplicity is just going to be the power that's added onto that. So it's x minus 5 to the third power. This is the factored form of these zeros. Okay, moving on to number 9. It's just more of the same with multiplicities. So the negative 2 for a 0 gives us x minus negative 2. And then it has a multiplicity of 2, so that means it's to the power of 2. And then we have x minus 5, which is our other 0. So subtracting a negative is the same as plus, so it's x plus 2 squared, and then x minus 5. And you can leave it like that in factored form. All right, the last problems that we deal with on this worksheet are the average rate of change problems, but this is really just secretly slope. So just finding the slope of, 2 points. When you need to find the slope, you need 2 coordinates, so here's how you get them. These values right here, this interval over which we're finding the average rate of change are 2 x values. So if I'm putting together 2 coordinates, I already have the x values. One of them is 0, the other one is 10. And then we need to just find the y values. To find the y values, you use your function. So this finds the y values. So if I plug in 0 for x, I get 0 squared plus 7 times 0 plus 12. So 0 plus 0 plus 12, which is just 12. Then if I plug in 10, I get 10 squared plus 7 times 10 plus 12. So that's 100 plus 70 plus 12. And if you use your calculator for that, you get 182. So 182 goes over here. Now we just do the slope. So remember to do slope, you label your coordinates x1, y1, x2, y2, and then put it into the slope formula just to remind you what the slope formula looks like. M is equal to y2 minus y1 over x2 minus x1. So we do y2, 182, minus y1, which is 12, over x2, which is 10, minus x1, which is 0. So 182 minus 12 is 170. 10 minus 0 is 10. 170 over 10 is 17. So that's our average rate of change. That's all that you need to do. It's just really just slope. Okay, so find the coordinates through the slope formula. That's the game plan for the whole thing. All right, so once again, we have our x values here. So negative 4 for one x value, 4 for the other. Now we need to find the y values, so we plug them in. Negative 4 plugged in there, we get negative 4 squared minus 4. So that's going to be 16 minus 4, which is 12. And then we have 4, so 4 squared minus 4. 4 squared is 16, 16 minus 4 is 12 again. Now we use the slope formula, so we do y2 minus y1 over x2 minus x1. So we get 0 over 8, which is still just 0. So 0 is our rate of change. And then the last one, number 15, here are x values. So one x value at 0, another one at 5. Now we plug them in, so if I plug in 0, 3 times 0 to the third, plus 14 times 0, minus 5 times 0. So that's just 0 plus 0 plus 0, which is 0. Then if I plug in 5, 3 times parentheses 5 to the third, plus 14 times parentheses 5 squared, minus 5 times parentheses 5. 5 to the third is 125, so that's 375. 5 squared is 25. 14 times 5 is 350. And then 5 times 5 is 25, so minus 25. So that's 350 plus 350, so 700. Let me verify that using my calculator because I'm a little bit hesitant to move on. Just I want to make sure. So 3 times parentheses 5 to the third power, and then plus 14 times parentheses 5 to the second power, and then minus 5 times parentheses 5. And we get 700. Yeah, okay, so 700 was the right answer there. Now we do the slope to find our average rate of change. So it's going to be 700 minus 0 over 5 minus 0. So that's going to be 700 over 5. And let's see here. What is that? It's like 140 maybe? I don't know. 700 divided by 5. Yeah, 140. Okay, so 140. That's our rate of change. And we are all done with the worksheet for 2.4.